시작해주세요.
네, 안녕하세요 여러분. 오늘 Human AI Collaboration, Past, Present and Future 세미나의 모더레이터를 맡은 전영훈입니다. 바쁘신 와중에도 사람과 인공지능의 협업이라는 주제에 관심을 가지고 참석해 주셔서 감사합니다. 오늘 세미나는 단순히 AI가 얼마나 똑똑해졌는가를 보는 자리가 아니라 사람과 AI가 어떻게 함께 일할 수 있는가, 그리고 그 협업이 어떻게 설계되어야 하는가를 깊이 있게 이야기해보는 시간입니다. 오늘 함께 해주신 연사이신 크리스티나 코나티 교수님은 캐나다 University of British Columbia 컴퓨터 교학과 교수님이시고요. 지난 25년 넘게 Human Centered AI와 AI 개인화를 연구해 오신 이 분야의 대표적인 연구자이십니다. 오늘 세미나는 약 45분간의 교수님 강연이 진행된 뒤에 이어서 Q&A 세션을 통해 자유롭게 질문을 받는 순서로 진행하도록 하겠습니다. 참석자분들께서는 강연 중 자유롭게 채팅창에 질의응답 링크가 올라갈 거예요. 해당 링크로 접속하시어 질문을 남겨주시면 좋겠습니다. 금일 진행은 영어로 진행된다는 점을 양해 부탁드립니다. 이를 위해서 크롬 브라우저 자동 번역 기능 안내를 저희가 신청하신 메일로 보내드렸습니다. 필요하신 경우 해당 메일을 참고 부탁드리며 발표 이후의 Q&A 역시 영어로 진행될 예정이나 한국어 질문이 편하시다면 한국어로 남겨주시면 제가 또 잘 전달해 보도록 하겠습니다. 각설하고요. 이제 더 자세한 이야기를 듣기 위해 프로페서 코나티를 모시고 Human AI Collaboration, Past, Present and Future 강연을 시작하도록 하겠습니다. Please join me in welcoming Professor Cristina Conati. And Professor, the floor is yours.
Okay, thank you for the kind introduction, and thanks everybody for taking the time to attend my online seminar. As probably the introduction just said, I'm a professor in the Department of Computer Science at the University of British Columbia. I'm also collaborating here with professors at Sauder University as well. So, and my research that I will discuss today, just to give you a little sense of what I do, it's at the intersection of artificial intelligence, cognitive science, and human-computer interaction, with the goal of supporting human AI collaboration in a specific way, meaning building, understanding, and investigating how to create AI tools and agents that during the interaction with their users, they can understand relevant properties of their users, such as needs, states, and abilities, personalize the interaction accordingly, and do that while preserving transparency, user control, and adequate user reliance on the AI advice. So, and that's why this research is considered human-centered, because it's very important to take the human into account when building these AI tools. So in terms of what needs to be done conceptually to create this AI-driven personalization, as I said, it's research that combines AI, which is my background, and human-computer interaction. And I'm going to talk about three different components and where the AI and the HCI will fall. So the first thing that needs to be done by the AI, of course, is to be able to understand the user. Different properties could be relevant, including, for instance, understanding what are the user goals during the interaction, what is the user performance during the task, what is the user domain knowledge on the topic of the interaction, and also other things such as cognitive abilities, user emotions, personality, preferences, and there are dots there because these are just some of the examples of the properties and states that researchers in this field have worked on. And these are things that require AI techniques, that's where the AI come into place, to infer these properties from limited and noisy interaction information. As you can imagine, even when we have human and to human interaction, it's possibly not always easy to understand the goal of our interlocutor, their emotions, their personality. It's all very uncertain, and that's where the AI come into place. In order to, the information that the AI can leverage include obviously interface actions that the user is performing, scrolling on your phone, typing on your keyboard, talking to your Siri or Alexa. But the researchers have also looked at other signals that can be used to provide the AI with more information to make inferences about the user. And the signals include physiological signals, such as information that can come from a smartwatch and then can give information about user emotions, facial expressions captured by a camera, speech, if the user can speak to the AI tracking, which I will talk a little bit more in the rest of the presentation. And once the information about the user is being built in real time, the next step is to use AI techniques to decide how to provide suitable personalization. And what suitable personalization means, it depends on the interaction and the task, but researchers have worked on enabling AI to provide help to the user, to tailor the information, change how the information is presented so that it's more clear for a specific user, providing recommendations, adapting the interface. And this is the part of the research where the human-computer interaction aspects come into play, because any action that the AI performs needs to be, meeting usability criteria and to have to be acceptable by the user. So to give you some examples, so this research in AI-driven personalization has been going on for a long time, way before GenAI came out 2 or 3 years ago. Some examples of this research include, or applications that have resulted from this research include recommender systems, anything that you have used from, recommendations of movies, dating apps, food, intelligent tutoring systems, meaning AI systems that help people learn from educational software. There are applications in smart homes, personalized health, assistive technology, and so on and so forth. But it's important to understand some concepts. So that's what I'm going to do in this slide. So when I say AI-driven personalization, if you read papers on this topic, sometimes you will also see terms called adaptation or user adaptive interaction. There is also something called user-driven personalization, also called as customization. This is when the user decides how to personalize. Not the AI, but the user decides, meaning there are ways in the interface for the user to change how the interaction is performed. For instance, when you are providing prompts to your favorite large language model, you are customizing how the model reacts to you. It's not the model that does it. It's you telling the model how to personalize. To give you an example. Anyways, these two are complementary approaches. There are times when it's good that the AI drives the personalization, and there are times when it's good that the user drives the personalization. So this interaction is called mixed initiative because, the best way to create this AI human collaboration is to have both working together and be in the middle, in the spectrum of the user doing all the work or the AI doing all the work. In terms of the work that I have done in AI-driven personalization, with my group, we have looked at applying AI-driven personalization for creating intelligent pedagogical agents that can help people learn. I've also done work on creating intelligent agents that can help users work with complex interfaces and complex systems. I've done work on providing personalized guidance as users are looking at difficult or complex presentations and information, including complex visualizations. And I've done quite a lot of work on AI-driven support for healthcare. So what I'm going to do in the rest of this talk is to give you a couple of examples of the work that we have done in my group in this space. And then I will move on to talk a little bit more about the present and the future. So I will start with this work on personalized guidance to visualization processing. And why is it important to help users understand visualizations? Is because these days, visualizations are everywhere. It could be, from your app, about your lifestyle, how much you eat, how much you exercise, to, in university, to show complex statistics in a company to analyze their assets and their trends. But visualizations can be difficult to understand. So there is a lot of, so they're everywhere, but there is great potential and need for personalization to help users digest complex information displays. So if we look at personalized guidance to visualization processing, what needs to be done by an AI system that wants to help users with looking at complex information is to, of course, find ways to guide their attention in the way that facilitates processing these visualizations. And what the AI needs to know in order to guide and provide help to the user is information about the user attention, how the user is looking, information about whether the user is comprehending or understanding what's happening in the visualization, capturing states such as confusion. Is the user confused about what they're looking at? But also possibly understanding user perceptual skills. These are perceptual abilities that describe how well a person can deal with visual information. And of course, the information that you can get, that the AI can use, can still be interface actions if the visualization is interactive, but a lot of the information needs to come from eye tracking because all the user is doing is looking. So let's see what this eye tracking technology does. In a very simple terms, eye tracking are devices that track where a person is looking, either on a display or also in the wild in 3D. But here, this picture relates to looking at a specific display, and an eye tracking returns information about fixations, these circles here, 1, 2, 3, 4, meaning where the user is looking and for how long. And then saccades, there are just these blue lines that tell how to go from one place to another. I'm going to show you here a couple of examples of eye tracking devices. This eye tracker here in the center, it's a very, very high-end eye tracker, but it's also one that obviously it's very intrusive for the user because it needs to be put in the user head and the user is constrained with the chin rest. So very good, but not very usable. But these days, eye trackers are very, very lightweight and portable. This little bar that is shown to the right is an eye tracker that is super expensive, thousands of US dollars, but you can attach it under any monitor and it will see what the user is looking. And then there are eye tracking glasses that you might have heard of. So using eye tracking for AI-driven personalization is crucial for tasks that are mainly perceptual in nature, reading, processing visualizations. But there is a lot of research showing that information about gaze, where the user is looking, is useful for modeling most interactions. And also eye tracking devices also give information about the size of a person's pupil in the eye and how that changes during an interaction. And also information about the user's head distance from the screen. And both of these are measures that are very important to capture things such as cognitive and affective states. So I'm now going to play a video that shows an example of how we have, we built an AI system that helps users in looking at complex information using eye tracking.
At the University of British Columbia, we have developed a software platform that can support the design and delivery of adaptive information visualizations. Adaptations are delivered according to eye tracking data captured in real time. In this video, we will demonstrate example adaptations provided by our software platform. This example will show a user processing a document containing both text and visualization. Magazine-style narrative visualizations such as this one typically contain distinct sentences in the text called references that refer to specific bars in the visualization. For example, this document contains two references. The first one consists of this sentence and refers to these two bars. The second reference sentence refers to these two bars. Reading documents such as these can be challenging due to the need to go back and forth from the text to the chart, and can become increasingly difficult as the number of references increases. We use eye tracking to monitor what sentence the user is currently reading in the text. The moving red dots indicate the locations and durations of the user's fixations. When a specified number of fixations are detected over a given reference sentence, then the corresponding bars in the visualization are highlighted by de-emphasizing non-relevant bars. When a different reference sentence is read by the user, the highlighting is updated accordingly. Additional forms of highlighting are also possible. For instance, here we provide a red outline in addition to the de-emphasis. Different users could therefore receive different types of highlighting, allowing for personalization of the adaptations.
Okay, just to clarify here, to summarize, the user is looking at this information that is text plus graphics. There is an underlying AI system that we built that tracks where the user is looking and decides when to provide these highlights. And the details, I cannot go because there is no time, but there is a reference and you can look at the details in that paper. But because, as I said, in this research, it's very important to make sure that we deliver AI tools that are actually useful. We always want to evaluate if this AI-driven personalization is actually working and achieving what it's supposed to achieve. So in this particular work, we ran a user study where we had users look at these documents without any help from the AI, and another group of users looking at documents and having this AI-driven personalization. They looked at a series of documents, and after every document, they would need to answer questions as to see if they understood the content. And then we checked which group was more accurate in answering the questions about the documents that they read. And as you can see in this graph, the users, so the red line is users who were working with the system that provided AI-driven personalization, and the blue line is the people who didn't have any help. And as you can see, on the left, there is the group with the adaptive help had much higher accuracy. And this is a group of users that have what it's called low visual literacy. Visual literacy, it's a perceptual ability that is similar to reading proficiency, but for visual information. And people with low visual literacy, meaning they're not very good at processing visual information, but with these AI-driven interventions, they actually did much better than without. And these interventions did not help the other users with medium and high visual literacy, but they didn't hurt. So that's completely fine. The important thing is that the AI helped the users who needed help the most. Changing a little bit gear, we're gonna talk a little bit about some work that an example of AI-driven personalization for intelligent pedagogical agents. So this field of AI-driven, it's also called artificial intelligence in education. It's exploding now because a lot of people are using LLMs for these purposes. but there's research in this field is also going on for several decades. This handbook that is shown in the slide summarizes work in the 10 years until 2023 about. So all the work that was done before GenAI. And there has been a lot of success stories on devising this AI-driven intelligent tutors to help people, students, learners, solve problems. So if you're a student and you go to class, then you get assignments, and often they are problems. If you're taking a physics class, it could be physics problems, or computer science, programming exercise, algebra, and so on and so forth. So here, the AI can help you as you're solving a problem. If you get stuck, they can provide solution, and so on and so forth. So a lot of work on this, but there is also other types of intelligent AI-driven learning environments that support other activities different than problem solving. And these are called activities that support learning through exploration, meaning you're given tools to explore a domain and learn from it. And these tools include educational games and interactive simulations. I'm going to give you an example. So Unity CT is a platform that was designed by a company in Vancouver. That's where my university is. This UME Academy is the company, and that they designed this platform, Unity CT, based on the Unity game engine, designed to help kids age 8 to 12 years old to learn computational thinking skills. So not so much programming, but understanding how to think computationally. So, and essentially this platform works as in students are giving objectives for designing specific games, and they have to use the platform to design the games themselves. So they have a variety of actions available, and they just need to experiment with the actions and the things that the platform provides to build a game that does what it's supposed to do. Okay, so here are just some examples of games that were built. And obviously they're fun because the kids really enjoy building the games themselves. And before COVID, so before 2020, this company was giving this, the kids would be using this platform in person during specific workshops that they would be doing during school breaks or after school, with an instructor, the person that you see in the picture here, that would provide help if the kids needed help, because it's not easy, of course, to use the platform and to get a game and to build a game that does what it's supposed to do. But after COVID, the company decided to put this platform online so that kids could access it anytime and work with the platform anytime they wanted. The problem is, at this point, there is nobody to help them. So the company came to us and asked if we could have AI agents that can actually be a substitute for the human instructor and provide a kid playing with this platform help when they need to. Now, from the AI perspective, this is tricky because there is no clear definition of correct or effective behaviors, meaning how a kid should go about building the game. The solution is clear, but how to get to the solution is not. So for the AI, it's difficult to understand what's happening and how to provide support effectively. This is true in general for these open-ended interactions with educational games or interactive simulations, because again, it's difficult to give the AI information on what are the correct or incorrect behavior. But in our lab, we built this AI platform that is called Framework for User Modeling and Adaptation that combines a variety of AI techniques. I will not go into the details because it's too much, but you see a graph below here to show you that there's a variety of things that need to go in there. But essentially, what the platform enables to do is for the system to learn what from data, from existing data sets, what user behaviors are good or bad for learning. And then in real time, as a new user works with the system, recognize and react to these behaviors in real time during the interaction to provide hints that can help students work better with the system. So it's a bit high level and vague, but I'll give you an example. So we applied this AI framework for many different environments, interactive simulations and games. But today I will give you an example of how it works in this Unity City. So essentially, as I said, as a student is working with this Unity City to build a specific game with specific objectives, all the actions are tracked by the underlying AI agent that takes this action informations and make inferences of whether the student is learning well, and if not, if the student is showing suboptimal interaction behaviors, actions that are not good to achieve the purposes of building the game that they have to build. And then the same AI framework takes this information and uses it to decide which help to provide to the player. So this is the part. So the first part of the cycle is all the AI that does the work. But at some point here, it was also very, very important to talk to the experts from the company, this Yumi Academy. And they have user experience experts and instructors who told us how to actually frame the help and design the agent so that it would be effective and would be accepted and followed by the players, by the kids. So just to give you some examples. So first of all, this agent has been embedded into this Unity City and has been deployed in the wild, means that it's live and there are students who are using this agent all the time. We collected data on the usage and the solutions that the students generated, because we wanted to see if the agent was effective. And just to give you examples of what the agent, the kind of work, help that the agent provides to a kid who might be showing a little bit of confusion or not very effective interaction with the tool, it would say something like, did you know you can test your game? Because this is something that kids often don't do. They build the game, but they don't test it. And the player can say, if they want, they can ask for more help and say, what can I do? How to do it? I don't know why it's not working here. And if they want to have more help, the agent would give you more information. For instance, you can test your game by hitting the play button. Remember to click the play button again once you are done testing. Or the agent could say something about specific properties of some of the game objects, which the player might have overlooked. Do you know that each color platform has some powers? And if the player wants, they can ask for more help, and the agent will show how this works. So the interesting thing, as again I said, it's very important to see that these agents are actually achieving the objectives that they are designed for. Here, it would be to help players create better games so that they can learn better from this interaction. And in fact, in this paper that is shown here, we have results showing that when the players play with this AI agent that provides personalized support, they actually create better games and better solutions. So this is also very exciting, especially because this was done in the wild, not in a laboratory setting. Okay, great. So, so this is some of the work that we've done, and there is a lot of other work that other researchers have done. As I said, there is this work on AI-driven personalization has been going on for a long time. What I'm showing here are some of the publication venues, journals, and there are also conferences where this research is published. And if you read papers from these journals, you will see that there is extensive evidence that AI-driven personalization can support effective human-AI collaboration, okay? So these are lessons from the past. Other things that you will see if you read this literature is that in order for the systems to be accepted and work well, it's critical to involve users and other stakeholders throughout the process of designing these agents. And it's also very important to have rigorous evaluations of these agents and tools that check whether having these agents improve user performance, but not just performance, also satisfaction. The users are happy about having these agents, which it's not always the same as having good performance. So these are some of the lessons, but other things that you will see if you read this literature is that obviously until GenAI, so a lot of the underlying AI that you see in the systems, I didn't give the details, but there is a lot of machine learning, there is a lot of decision theoretic reasoning, probabilistic techniques, these deep learning when possible, to build the systems require having AI experts. And they also were very domain specific. And if you build a system, for instance, for an agent in UnityCT, it would be difficult to generalize to a different system. You would need more experts to look at a different system and change it and so on and so forth. So they tended to be very costly and resource intensive. But now we have GenAI. So that's our present, which is great. Okay, well, so first of all, if we think about this AI-driven personalization, there is limited evidence that GenAI can build information about the user from user behavior, so the bottom part of the loop. There is some work on having GenAI and LLMs to align to values. They're more like societal values and moral rules and user preferences with some deep learning techniques for users voting on which LLM answer is best. But this is just a small part of what AI-driven personalization is. So in terms of building user models and understanding the users, the GenAI is still not, it's still not understood how well it can do that. But GenAI can be very good at responding to user requests, to prompts, so can be customized. So that is really good. The good thing about GenAI, and possibly also the scary thing about GenAI, is that everyone has access to some GenAI model. Everyone can make this model do things. And the answers that GenAI brings back or gives back look really nice because they are in very good natural language, English or other languages when available, and also very good visuals, images, videos, okay? So the output looks good. It's easy to get from the GenAI, easy. I mean, sometimes not always, but definitely anybody can try. But what are the problems? Well, the problems, I mean, everybody is talking about this problem. But just to remember what they are, GenAI models can hallucinate and misbehave. Of course, there is a lot of research on guardrails and ways to guide GenAI models to alleviate these problems, but the problems are still there. And it's also unclear what these models can and cannot do well. We know that often these beautifully looking answers are not necessarily correct. They can be misleading, they can be partial. So it's very unclear what can be done, for instance, in terms of, using GenAI to support critical human tasks. And when I say critical human tasks, I'm talking about human tasks that have high stakes. For instance, still unclear how to best use GenAI to support learning. Everybody's grappling with the idea, like, should students use GenAI for homework in class? Should teachers use GenAI? I am the editor of a journal of AI in education, and we get tons of papers about these topics, but these papers often bring up more questions than answers. And for instance, in our department, with some graduate students that I'm co-supervising, we conducted a study with instructors and students about how they use GenAI. And we found that instructors are they're still very uncertain about how to use GenAI. And they would say things such as, would using GenAI undermine, meaning reduce or interfere with the learning objectives of my teaching? Will students still be able to practice the core skills if they use GenAI? Would they acquire the skills if they use GenAI? So most of these instructors, what do? They don't prevent the students from using GenAI because that's practically impossible, but they say you might use AI tools like ChatGPT as long as it doesn't replace your own work, which kind of makes sense. But if you talk to students, they would say, okay, well, what does that mean? What about using GenAI to rephrase my sentences, improve my language? Is it considered replacing my own work? Is it okay to use it for idea brainstorming? Am I allowed to summarize readings with it? Because again, the guidelines and the understanding that they get about how to use GenAI is very unclear. Another critical human task is healthcare. And again, that's another space in which everybody's thinking about what is the best way to use GenAI? What are the good things and the bad things? So there was a workshop at UBC, Yale University, a couple of weeks ago, and brought together patients, doctors, computer scientists like me. And it was 2 days, and it was all about, good stories about having GenAI in specific aspects of healthcare, but also stories in which using GenAI was not working very well. And specifically, for instance, I'm collaborating with someone from the School of Medicine in relation to integrating AI tools and GenAI into cancer care. Cancer care is something very specific because curing someone that has cancer is something that can take a long time. And it's not only diagnosis, but it's also deciding on treatment, and is also providing psychological care. So my colleague from the School of Medicine ran a user study to understand how different stakeholders, patients, families, clinicians, researchers, administrators, how they perceive, how they feel about using AI for helping with cancer care. So here it was part of a big conference on that is always organized every year by the BC Cancer Institute in Vancouver. And here there were 48 people. They were grouped together in groups of 6 to 8, and they were asked to give their opinions about concerns, benefits, and priorities of using AI into cancer care. And it's interesting because, a lot of the things that they discussed, they brought out, were concerns. There's 88 comments. And things about, such as, again, I won't go into the details. There is a paper if you're interested in, but some of the concerns related, of course, about errors, hallucination, the fact that AI models can be biased, the fact that using too much AI could reduce the doctor's expertise, accountability. If someone makes a mistake, who is accountable for that mistake? The AI, the doctor, the hospital, the government, who knows? But there were also people were discussing benefits. Not everything was negative. AI can help alleviate doctors from tasks that would take a lot of time, so they can improve efficiency, so that now doctors have more time for important things, such as talking to patients. They can provide cognitive support to doctors and patients, and they might be able to improve patient understanding of what they have and the diagnosis and the doctor reports, because GenAI, that's used in large language model, can rephrase this information in a way that it's easier to understand. And priorities, people were very keen about making sure that AI models maintain equity, transparency, they can, we can understand what they're doing, usability, and trust building. So these are all very interesting things. I'm just going to give you a couple of examples of some of the comments. So a lot of the comments related to this idea that AI should be explainable. People should be able to understand how an AI model is reasoning and why a certain output happened. They said things like, can we interpret the AI results? Can we know whether the AI results are reliable? How do we let users believe about AI model suggestions? And they were also very much concerned about, making sure that AI doesn't impact doctor-patient relationship. Because if the AI is in the middle, it might reduce the time that doctor and patients have to talk and understand each other. And of course, if you think about it, it's very, very important that the AI doesn't interfere, especially when we are in domains that have very high stakes, including obviously cancer care, because here decisions would be, should I have a very intrusive surgery or go for palliative treatment? So it's very important that the system are explainable, and they are explainable in a way that it's helping all different, and it's understandable by different types of users, such as in this case, patients and doctors. So some work that we have done in my lab is that of personalized explainable AI. I want to have time to go into the details, but we can talk about it if you're interested in the Q&A. So to conclude, we'll just skip this. The future. In my talk, I said I would talk about the past, the present, and the future. But of course, the future, who knows? I put here this crystal ball, because everybody's kind of, grappling about what is going to happen with this explosion and this big revolution brought to bear by GenAI. I, like many others, don't have a crystal ball to predict the future. But what I know is that the things that are very important to understand how to use GenAI at best include these that are in the slide, including human-centered design. Always include users from the very beginning and listen to what they actually want and how much they are comfortable having AI and GenAI in their tasks, as we did in the workshop that I described. AI literacy is super important. AI literacy means not everybody would need to understand the details of how large language models work, because you need a degree in computer science to do that. But AI literacy means to educate people about the pros and cons, not the pros and cons, but the possible limitations of these models, because it's too easy for people who are not expert to become over-reliant and overconfident, because these models in surface behave really well and give you, as I said earlier, these really beautifully looking answers. Super important to do model evaluation, evaluate these GenAI models. If you go to any conference on large language models, one of the main topics these days is evaluation and benchmarks, providing large data sets and tasks that should be used to evaluate these models, understand their accuracy, understand what they fails and how they fails, to understand how to fix them. Policies and regulations, of course, these are up with more like the governments, and again, something that every government is grappling with, and some governments are more ahead than others. But again, something that everybody needs to work on more. And then, of course, explainable AI. So creating techniques from the AI standpoint to be able to make these models as transparent as possible, although that is, of course, hard because these models are big statistical models where even the experts don't quite know what's happening and how certain answers are generated. And last but not least, really try to understand this idea of foster this idea of just right reliance, which is connected with all these other points of AI literacy, explainable AI, model evaluation, meaning helping people understand how to, when and how to rely to an AI answer, accept it, and when to think about maybe not, maybe that doesn't look good, maybe this is where the AI is not accurate and I should not accept the answer. So I think I ran out of time, so I'll just end here so that maybe we can have time for questions, and thank you again for your kind attention.
All right. Thank you very much, Professor, for the insightful lecture. It was truly a pleasure to learn from you, and I appreciate the fascinating result findings that you shared with us today. And since we have lots of questions waiting for you, let's just move on to the Q&A sessions. And let's see, the first question here is that, do eye tracking behaviors exhibit distinct tendencies based on age or gender? Furthermore, during the model's training, does it rely solely on real-time inputs, or does it incorporate broader behavior patterns?
Okay, that is a fantastic question. Thanks for asking it. So the first part, do they exhibit distinct tendencies for age or sex? I am not sure about sex. We have never done any study for that, and I don't know from psychology literature, I haven't seen any of that. So probably is not something that has been investigated much. In terms of age, certain things, so there is one ability that is called perceptual speed, that is how fast one is at processing visual information. This kind of ability, for instance, decreases with age, okay? So that would impact how someone, the eye tracking behaviors for sure. And it says if the model training does rely, so no, real-time input. So the real-time input is used for input. So we build these machine learning models that are trained on existing eye tracking data, which is a bit challenging because there aren't very large corpora. So some of the challenges of this research from a machine learning AI standpoint is how to build these machine learning models when the data sets are not large. But we build the machine learning models using these behavioral patterns, exactly how this, these behavioral patterns. And then the real-time input is used as input to the machine learning model to make predictions on a specific user at a specific point in time. So I hope I answered the question, but excellent question. Thank you very much.
Thanks for the answer. And let's move on to the next question. So the next question is written in Korean. It says, since using human interaction as input is essential for building adaptive systems, determining which types of interaction to capture also seems very important. So how do you decide which forms of human interaction should be selected as input?
Oh, this is another fantastic question. So, well, first of all, the first necessary type of information is whatever comes from, if you want to build an AI system that helps someone work with, the type of application that I showed, for instance, that Unity CT, the actions, the interaction was all in interface actions. So that's all we could use. And then some of the work goes into logging these interface actions and use those to make the inferences, because that's all you have, okay? The other work that I showed where the system was using, the eye tracking. Of course, you need to use eye tracking because otherwise there wouldn't be too much more information to use. Now, if possible, researchers have looked at even this work on the Unity CT. We haven't done it, but one thing that would be good to do is to, for instance, use a webcam to capture facial expressions and put the facial expressions also in the mix of data that the AI can leverage, because facial expressions from the user can give a lot of information about whether the user might be need help or be confused or be upset. So if possible, it's good to have what we call multimodal information. But in the case of that particular application, it wasn't feasible because we cannot ensure, for instance, that the user would have their camera on. Okay, so that would be too difficult to enforce. So which interaction events to take into account often depend on what is actually feasible and practical in a real world application. So thank you. Excellent question.
Thanks for the answer. And let's move on to the next question. So, as you mentioned, it's hard to distinguish between good and bad learning behaviors. And I think most services seem to focus on making learning easier by providing shortcuts. However, are there any methods that intentionally make the process harder to achieve better results?
Wow, I'm getting this. These questions are all amazing. Thank you so much. This is really another excellent question. And many methods intentionally make a process harder. Okay, so yes, some of the previous work on AI in education, when I say previous, I mean before GenAI, okay? So there is a lot of work that tries to use AI techniques to implement this very famous theory from education. It is called the zone of proximal development, meaning you should always give to a learner something that is at the boundaries of what they can already do and what they cannot do well yet. Okay, you want to give something that is difficult so that it kind of helps the learner challenge themselves and advance. But it shouldn't be too difficult, otherwise it can be frustrating. And obviously it shouldn't be too easy, otherwise, the person is not learning and is going to get bored. So understanding how to make it, as you say here, intentionally harder, it's something that has been done, but what it's important is that the AI understands what is the right boundary for that specific person, right? So what is it that the person already knows well? Say that you're looking at a programming exercises or math exercises. What the person has already learned and which concepts are still not very clear, so that one can choose an exercise or an activity that is challenging for the person, but is not too challenging. So this is something that has been done in the past, and hopefully, can be, revised and done again with GenAI. Yeah.
Thank you so much. And there is part 2 in this question. So it says, I assume that the platform's goals would change depending on the target audience, such as high achievers versus average students. Is there actually the case in the practice, such as the Unity CT that you showed?
So yeah, that's great. For Unity CT, we didn't do that, but we have a different system where we were actually, the AI was trying to capture exactly this, being a high achiever. So more than high achiever, so we were capturing, for instance, this, it's called learning attitude, meaning students were really trying to learn as much as possible, and they engage because they want to learn. But there are also students who want to just get done as fast as possible with some activity. And so in that case, the system, this was a case in which the system was providing help and was also explaining, in terms of explainable AI, how the help was, why that specific hint was provided. And it would be phrasing the help differently if the system thought the person was a learning-oriented student, or we call them efficiency-oriented students. So definitely something that is done, distinguishing between, you know, different intentions from the student's end and abilities. Yeah.
Cool, thank you. And next question is also written in Korean. And it seems like from these questions, we are talking about some future aspects of generative AI. And this question says, due to issues such as hallucinations, as you mentioned, many argue that it is still too early to apply generative AI to mission-critical jobs. So when do you think generative AI will become viable in high-stakes domains such as the healthcare that you mentioned? And within the healthcare domain today, which areas do you believe are realistically suitable for applying generative AI?
Yeah, okay. So this is in the space of the crystal ball, okay. But that's another excellent question. I mean, I don't have the answer, but the answer, it really is, you know, it depends on the research that I mentioned here. Really doing a lot of, so what happened when GenAI came out is that everybody was so excited that it was just put to use, and everybody was using it. And now finally people, researchers, and other stakeholders understand that before we use it in critical domains, is very, very important to do a much, much better job at understanding and evaluating and understanding the limitations and apply AI techniques to fix them. Okay, so there is a lot of work in that direction. When it will be done, I don't know. But what I know, for instance, I can give you one example of a success story of using AI in healthcare. This is from an invited speaker who came to our department. And he's a computer scientist, but he collaborates with doctors in this other province in Canada. It's called Alberta, where essentially they deployed state-wise a system that uses GenAI to help doctors summarize, transcribe, but also summarize the interviews with the patients. You know, when you go to a doctor, the doctor talks to you, and then it kind of transcribes the discussion so that they have a record. And there are transcription systems like speech-based, but they're not very good and they don't summarize necessarily. But GenAI can also summarize and bring out some inferences. So, but what's good about this system is that this researchers did a very thorough evaluation of this technology, of this GenAI technology they generated, and they saw that it wasn't 100% accuracy. It wasn't even 80% accuracy. Actually, accuracy was around 70%. Okay, but that's okay because the doctor gets the summary from the AI right away, and then they can check, right? And because they just interviewed the patient, they can use this GenAI output to check if something is missing or if something was misreported, and then they can change it. And then they are the ones responsible because they sign this in this report, this summary, and they so they are accountable. But because it's done that way, this tool is actually now in usage, apparently, in a lot of clinics and in a lot of doctor offices in Alberta, and is very successful because everybody is comfortable with the fact that, you know, the AI model is not 100% accurate, but it doesn't matter because the human can check and they can, you know, can collaborate with the AI to do a good job. So to answer your question, what are, you know, anytime we can define a space or a concept like this one, where somehow, even if there are limitations to the AI techniques, the humans can deal with these limitations and complement and address them, then I would say these are all very good, have great potentials for using GenAI, but that's where the human-centered design is very important. And of course, model evaluation. So, yeah.
Yep, thank you. We just have 1 minute left, and I think we can wrap up with one last question.
Yeah, that's great.
Yeah.
How do we balance personalization
Yes.
and privacy? Yeah, that's a fantastic question. So, for the applications I discussed today and others that exist, it was a little easier because, of course, the models were not models that were open. Not open in the sense that everybody, but they were not models that would just take your data and just do whatever with it, as some GenAI models do. So there would be applications that would be, the boundaries would be very well defined, and in general, the user would be asked for consent. So if I use eye tracking to provide personalization, of course the user would need to know and say, yeah, sure, I want, I consent with the system to track my gaze. And if they don't, that's okay. Of course, the system will not be as accurate, but the important thing is the user is always well informed and is allowed to give consent and decide, this concept of user control, and decide what, if they want their data to be used by the AI or not, and if it should be shared, if the system can share the data. So, but it's a tension that absolutely needs to be taken into account and always be at the forefront for any work for AI-driven personalization. Yeah.
Thank you so much for perfect 1 hour. The perspectives you shared highlighted the important considerations for us to, as we work to build AI systems that will ultimately be used by the public, and systems that must collaborate effectively with people and be thoughtfully designed for real human context. Thank you again for precious time that you gave us. And yep, that'll be all for today.
And thanks for your moderation. Excellent. Thank you very much. Thank you, everybody.
Thank you very much. Thank you.
Thank you.
네, 이제 마지막으로 마무리 전에 안내 말씀드리고 라이브 종료하도록 하겠습니다. 이번 세미나의 만족도 설문을 채팅창에 올려드렸습니다. 만족도 설문 많은 참여 부탁드리며 금일 강의 자료는 빠른 시일 내에 신청하신 메일로 전달드릴 예정입니다. 네, 그럼 이것으로 2일차 업스테이지 컨소시엄 세미나를 마치도록 하겠습니다. 감사합니다.